Good day, everyone. This is Harry from Start Quick Tech. Today, let's do some discovery on how AWS Network works. Let's go. Imagine you own a company with a factory producing the most leading tech products in the world. You have more than 500 employees working there. Some of them are production workers who work in the private area where all the machines are working and making products. But it doesn't allow external visitors for confidential purpose. Rest of the employees working in the public area such as office area, cafe, as well as the exhibition area with product showcase. All the workers in the private area are not allowed to be contacted from external, but they can make calls out to the teammates, friends, or families. However, people working in the public area can communicate freely no matter to external or to the people working in the private area. Everyone has its private identity for internal use, and only people working in the public area can apply public identity. Once you understand this, let's have a look at how AWS networking works. The factory is like a VPC, which is a virtual private cloud. This is a private virtual network with an IP CIDR range. The number of IP addresses is directly related to the size of the CIDR range. The public area is like a public subnet, and a private area is like a private subnet. The Internet Gateway is like the door of the VPC, which allows communication between the VPC and the Internet. If you create a new VPC, you need to create an Internet Gateway as a separate step. We use route table to manage the routes within the VPC. For the public subnets, we have a static route in the route table where the default route is to go to Internet Gateway. The VPC internal connections are also controlled by route table, as we have a route record which is using local as the target when the VPC CIDR range is the destination. You will see it in the hands-on video later. In order to have a private subnets which cannot be accessed directly from the internet, but we still need the instance in them can talk to the internet, we need Net Gateway, which is short for Network Address Translation. Regarding how Net works, I can do another session to explain if you're interested. Please leave your comments below. For the route table associated with the private subnets, the default route should be Net Gateway instead of the Internet Gateway. There is another type of private subnet which does not allow internet connection. We usually provision database in it. To achieve this, we just not configure the default route. Now, I have explained the basis for the AWS VPC networking. Let's do some hands-on for creating a new VPC with required configurations. I will do these two types of subnets, but leave this type of private subnet as your homework. You're welcome to ask questions in the comments. Let's get to the hands-on now. Okay, now let's go to our AWS account. First, we need to create our first VPC. Let's just click here. And now we can have a look at what the VPC that we have. This is the subnet region that I usually use. We can just go to any of the region, for example, like Singapore. We could say that there's already a VPC created in every region. And when we go here, we could say that the default VPC, it shows that yes, which means it is default VPC. And then when we click the Internet Gateway, we can see there is a specific Internet Gateway created, and you can see it is connected to the VPC, which is the default VPC. And when we click the subnets, we could see 3 subnets already created within that VPC as well. Oops, sorry. And if you don't need private subnets, we can just create our resources within the default VPC. Now I'm gonna show you how to create your own specific VPC in a region that you want. So for me, I'll select Sydney. So first, I'll click VPC. I'll create a VPC. So if you click VPC and more here, AWS gives you some new VPC experience. You can just go through what you have. You can pick up different availability zones, number of public subnet, private subnets, and select a NAT gateway if you need it, and select F3 gateway if you really need it as any VPC endpoint. We're not gonna do that. We're gonna use our own method for you to better understand how it works. Okay, so we just create a VPC. We call it Start Quick VPC. And in order to make it simple, we just use IPv4 only. So we give it a data range. We use 10.0.0.0/16. And we can create. So now the VPC is available. So we can click the internet gateway. So there is an internet gateway, but it is related to the default VPC. We don't have an internet gateway. We're gonna create internet gateway later. So we click subnets first. And then we create a subnet. Here we need to select the VPC. We'll select Start Quick VPC. Okay, so here we'll create the subnet 1. In the real cases, we usually need to create multiple subnets, but in our examples, we just create one subnet, public subnets, and one private subnets. So we create public subnets like this. We don't need to pick up the preference. It'll randomly locate the subnet to availability zones. So here we need to give it a set a range, which we're gonna use /24. This range must be within the /16 range, which is for the VPC. So we just create one VPC here, a subnet here. So now we have the VPC and subnets. Okay, so next step, we'll do some testing. So go to EC2 instance. We're going to launch a new instances within the VPC. So we call it EC2 instance 1. We just give it an Amazon Linux operating system. We don't want to change anything. We go scroll down. We can select Start Quick Tech Key, which is what we use. And here for the network part, we need to click Edit. Now we choose Start Quick VPC. We only have one subnet, and we can enable auto assign public IP. We need to create a security group. Let's have a look if we have an existing security group that can be used. Oh, no, we don't have that. We'll just create a security group. Give it a name called allow SSH EC2. Okay, and we're gonna allow SSH from anywhere, for testing purpose, but it is not recommended to do that in the real build for your environment. And then we scroll down, we just launch the instance. And let's have a look at the instance. We probably need to wait a couple of minutes. It's now says running. Status check is initializing. Yeah, now you have a public IP address. So now what we're gonna do is we're gonna connect that. Click here. I've already got connected. Click it and select. So what we are gonna do is we're gonna run this command. Let's open up a terminal. I usually store all of the key files sitting in one of the folder, and then we just need to copy paste this one and clean up. Let's see if it can be connected. Yeah, let's try it again. Yeah, here we can see that we got a public IP address, but if we scroll down, do we have a private? Oh, yeah. Okay, now let's try connected. Let's copy this one. Let's open up a terminal. You could say even if we have the security group script set up already to allow SSH from anywhere, we can still not enable to access that one. So what we're going to do is we need to have our internet gateway for us to allow the instances sitting in that VPC to connect or to communicate to the internet. So let's go back to the VPC page. Yeah, this is our VPC, right? So we click Internet Gateway. Let's now create an Internet Gateway. Start quick GW. Just create this Internet Gateway. So now that you can see the state is detached. So we click Action, Attach to VPC. So here we'll click select the Start Quick VPC, and then we attach the Internet Gateway. So now the new VPC has an Internet Gateway. Let's go back to this and let's try and reconnect again. Still doesn't work. Do you know why? Yes, we need our route table to be configured. So Control C, let's quit that one, and then we go to the route table. Now if we look at this, we've already created the route table. Honestly, it is created automatically by when we create the subnet. And we click here. So we could see, oh sorry, click the wrong button. So this is the route table. We just click the route table. We can see this route means within that VPC, every resources within the VPC can be connected to each other. So the next hop is local. So what we need to do is we need to edit the routes. We add a default route, which is /o, and we select Internet Gateway. Okay, which is the Start Quick Internet Gateway, and we save change. Right, now once it is done, let's go back to this and let's try connect it again. Now we can connect. Right? You understand how it works. So if you want your VPC can be connected to the internet, you have to create a internet gateway, and you need to update the default route in the route table to the internet gateway. That's how it works, right? Cool. Okay, let's go back to the AWS console. Now we have our public subnet created. Now we need to create another subnet, which we're going to use it as a private subnet. So let's create a subnet. We select VPC, and we give it a name called subnet 2. We don't need to select availability zones, and now we give it a separate IP range, which is we're going to use 1-0.024. Okay, this is subnet 2. Create subnet. Now we could see that we have two subnets for our own created VPC. So this one is we're going to use as a public one, and this one is subnet as the private one. Okay, now what we're going to do is we're going to go back to the EC2 instances portal, and we're going to launch another EC2 instance. EC2 instance 2. Okay. No configuration change. Keep here. We'll keep selecting this one, but we need to change the network settings. Here we need to select Start Quick Tech VPC, and then we select subnet 2. Auto assigned public IP, we can enable it and we can disable it. It doesn't matter because that one is sitting in the private subnet, so we don't have to, so we just disable it. And then we select security group. So the security group we're gonna use, it's not gonna use SSH. For this example, we're gonna test if the connection is working. So here we're gonna change it. We're gonna use allow ICMP. So we're gonna use ICMP to test the connection. We scroll down, and here we're gonna select ICMP. Okay, anywhere, right? And then we click Launch Instance. Sorry, let's have a double check what the problem is. Create security group, ICMP, security rule, allow inbound rule, anywhere, protocol. Oh, sorry, we shouldn't select custom ICMP. We should select ICMP, all ICMP, sorry. And then we launch the instance. Creating security group. Sorry, let's add an instance again. Let's double check ICMP, all ICMP. Add security group. Don't need that. Now it's working. I don't know what happened, to be honest, but it's not working. Just click that newly created instance. Have a look. So this one is sitting in the subnet. The EC2 instance 2 is sitting in the subnet 2, which we're going to use as a private subnets, because now we don't have a routing records configured in the routing table, so it is private. Absolutely, we can't access the EC2 instance via SSH because it cannot be connected, but we'll try ping it via the EC2 instance 1. So now we're still in that instances. So we just need to check that IP address for EC2 instance 2. Let's try to refresh it. Okay, it's not here. Just click it, scroll down. See, this is the private IP address. We just click it. Let's try ping it. Now you can see we can ping EC2 instance 2, which is sitting in subnet 2, from EC2 instance 1, which is sitting in subnet 1. So this means all of the instances sitting in that VPC can be communicated to each other. So that's what we're going to prove. Okay, now we have to allow the access from EC2 instance 2 to the internet. So to prove that, we still need to SSH to the EC2 instance 2. So how can we do that? We're gonna do some testing. What we're gonna do is we're gonna SSH the EC2 instance 2 from EC2 instance 1. Okay, so let's click EC2 instance 2, click security. We can see the inbound rules. Now we need to edit the inbound rules. Let's edit the inbound rules. So we can click SSH, but here we don't want anywhere can any. I don't want any instances can connect to it. Anywhere can access to the instance. What we can use is custom, or we're gonna use custom here. So we just need to select the security group for the SSH one, which we use for the EC2. So this will allow us to connect the EC2 instance 2 from EC2 instance 1. Okay, we save the rule, and we go back here from this instance. Now what we need is the SSH key, right? We don't have this key sitting in here in this EC2 instance 1. So what we're gonna do is we're gonna exit. We're gonna cat. So now we have the private key. Don't worry, I'm gonna remove this key. So it's not a problem, but in the real cases, it's better not share this key to anyone else. Now we're gonna copy this key, select copy, and then let's log back to EC2 instance 2, and then we're gonna use nano quick tech key.pem. Okay, let's save it. What we need to do is we need to change the permission for this file. Okay, now we have the key in EC2 instance 1. So let's go back to EC2 and let's double check the IP address. We don't have to know, we just connect to EC2. We just copy this one. That'll be. Yes. Now we are on EC2 instance 2, right? So what we're gonna do is we're gonna try ping Google. Obviously we can't do that because we can't talk to the internet. Someone will suspect the DNS issue. We just do this. See, we can't do that anymore. We can't do that, and if we exit, we can do same thing on the EC2 instance 1, which is sitting in the public. Yeah, it can be pinged, which means the internet connection is working. So now, how can we fix the connection via EC2 instance 2. So let's go back to EC2 instance 2. So now it's not working. So what we're going to do is we need to create a NAT gateway to allow instances within the private subnet connect to the internet. So let's go back to the VPC console. We click NAT gateway. We create a NAT gateway. Let's give it a name called Start Quick AT Gateway. We'll select subnet. We can create one NAT gateway per subnet, and we don't have to. We can create because we only have one public subnet. So here we just create one. So remember, we have to create NAT gateway within the subnet. Okay, within the public subnet. So we select subnet 1. So connectivity type was public. Elastic IP allocate ID. We don't have an elastic IP. We need to allocate an elastic IP. So this is necessary. And then once it is done, we create the NAT gateway. Okay, the NAT gateway is created. How we should do next? Let's go back to the route table. Let's have a look at the route table ID. If you look at that, the subnet associated, so both of them are implicitly associated to the subnets. So there's no explicit subnet association here, right? So what we're going to do, we need to create another route table. We just give it a name, route table for private subnet. Okay, we select VPC here, like this. And then now we have a new route table. And then what we need to do is we need to associate this route table to subnet 2, because that'll be used for subnet 2. We save association. Let's have a look. Once we explicitly associate the subnets, we'll say subnet 2 is not within this part. Okay, so even if it is done, we open up the terminal. Let's try pay it again. Still not working. I think you should know what's going on. So the problem is we don't have the route record setting for that. So here we click edit route. We add a route. This is the default route. We need to select the NAT gateway for this route table. So which means within the subnet 2, which is a private subnet, all of the default route is the NAT gateway. Okay, once it is done, we save the change. And then we open up a terminal again. You can see the ping is working now. Let's do it again. Cool, it works. The instances in the private subnet can connect to the internet. I think you should understand how it works. Let's go back to the slides to go through what the architecture looks like. After the hands-on session, let's quickly catch up what we have done. First, we created a VPC and a subnet and a VM in this subnet, but we cannot access to it until we created the internet gateway and route table with default route to the internet gateway. Then, we created another subnet and another VM in the subnet. We tested the ping connections between the instances are working if we allow ICMP via security group. But the instance in this subnet cannot connect to the internet until we created the NAT gateway and adding the default route to the NAT gateway in a newly created route table. Now you should know how AWS networking works. This is the foundation for you to understand how to build multi-tier application on the cloud. If you think this is helpful, please help click the like button. If you want to get more cloud or IT related content, you can subscribe my channel and turn on the notifications, then you'll never miss my next video. Thank you for watching, and I'll see you next time.